And to solve these equations, the first thing we're going to have to do is put it in exponential form. It'll make it easier on us to solve it. So, in exponential form, we know we have a base, an exponent, and then a final answer. In this form right here, in logarithmic form, what is our base? Do y'all remember? 6. Get this number. So we'll write this as 6 to the third, because that's our exponent, is equal to x. Good. Again, this will always be your base, exponent, final answer. So now to solve for x, all we have to do is what? Cube 6. So what is 6 cubed? 216. That's it. Anybody need a calculator? Okay. Wait, yours got down? Yeah. I have a charger. Can I borrow it? Okay. Your mind's on it, so you can unplug it and see your phone. Alright. Any questions about that one? Cool. Let's write the next one in exponential form. So this will be what? To the 3 over 2 equals x. And now solve for x. Tell me what you get. Yes, not all of them will be 216. This is just a coincidence. Mine, you can see if it'll turn on. I doubt it. Yeah. It's really good. But you can take the charger up there if you want to. It might reach. Okay. Did everybody get this when they typed in their calculator? Because some people are having trouble with different types. So make sure that you can get this on your calculator. Alright, did you put 3 divided by 2 in parentheses? Alright, let me come look at it. Okay. Make sure that you put 3 over 2 in parentheses, because sometimes it'll give you a different answer. Any questions about that one? Okay. So the next one, how will I write it? So what was x be? Go ahead and find that. Somebody said it. 32. Good. Did everybody get that on their calculator? Okay. Alright, next one is not tricky. They just swapped the log on the right side. So it's been on the left side. Nothing's changed. It's just on the right side. So what is my base here? Raised to the 3x equals. Alright, notice how the x in these equations has not been in the exponent, right? It's just been on the other side of the equal sign. So how do we solve it if x is in the exponent?
What were the 216 to match?
Cube root.
Yeah, we have to find a common what?
Exponent. No, base.
Base. Good. So we look at the smallest number, and this is what we just got through doing before spring break. We look at the smallest number. Is there anything that we can raise? Is there any number we can raise to a power to get 6? 3 to the what power? 3 to the 0 power is 1. It's not 6.
6 to the 1 power.
Yeah, 6 is the only thing we could raise to a power to get 6. Everybody see what I'm saying? You couldn't raise 2 to a power to get 6, or 3, or 4, or 5.
So you can't raise 1?
No, 1 to the 6th power would be what?
1.
1. Wouldn't be 6. So we have to leave this one as 6, so we know this base is going to be what? 6. And what do we have to raise 6 to get 216? Good. And what was the point of doing that? Good. And now we can set the exponents equal to one another and solve for x by dividing by 3. So anytime the x is in the exponent, you'll have to find a common base. Good. Alright, tell me how to write this one in exponential form. What would be our common base? 3. So this one's already 3. We don't have to change it. This one will be 3 to the... Check it. 3 to the 5th. Everybody agree with Darian?
Yeah.
Okay, so these cancel out. We'll have x minus 4 equals 5. So x equals
9.
easy peasy. Questions? Cool.
I think 243 is equal to 6.6.
Wait, when you do 243 raised to the what power?
Or cube root.
Right now we're just trying to figure out like what's the number we can raise 3 to get 243. So you don't have to do the cube root of 243. You just have to do like 3 raised to the 3rd power. If that doesn't work, do 3 raised to the 4th, 3 raised to the 5th. Any other questions on that one? All right. Darian, tell me how to write this one in exponential form.
4. 4x minus 20 equals 5.
This would be the exponent. What's the exponent? What's the exponent going to be? If we go back to this one, the base is always going to be right here. Your exponent's always this number. So this would be 4 to the 5th. Good. Equals?
4 plus.
Good. Alright, do we have to find a common base here?
No.
Why?
Oh, because
Yes, but what else?
because the other one doesn't have, it doesn't need an exponent because.
Nope, that's not what I'm looking for.
Okay.
Why don't we have to find a common base? We only do that when there's a variable where?
Oh, and the exponent.
As the exponent. Good. And this time the variable's not in the exponent. So like Isabel said, we're going to find 4 to the 5th power, which is what? Good. Equals 4x minus 20. Now how do we solve for x? Add 20. So when you add 20, you'll get what? Equals, and then divide by 4. So what does x equal? Very good. Any questions on that one? Okay. So these are a little bit different, 5 through 8, because they have logs on both sides. But it's pretty easy because just like these have the same base where we can cancel them out, if we look at this one, what's the base on this side? What's the base on this side?
2.
So they're the same, so we can also cancel them out. Same base, we can cancel them out. And now we can set x squared minus 4 equal to 3x. And now all we have to do is solve for x. So how do we go about doing that in this problem?
A times c squared.
Okay, we could do a times c, but first we'd have to do what?
We divide by 3. Or no, x, I mean. X.
Could we divide by x? Yeah, but then we'd have negative 4 over x. So then we still wouldn't have 1x. I know what you're trying to do. Okay, so subtract 3x from both sides. I like that idea. Yep, so 0 will be on this side. What will be on this side?
X squared minus 4 minus 3x.
Let's write it in standard form.
X squared minus 3x minus 3.
Good. And now we can see this is a quadratic, right? And we know how to solve quadratics. We can do it factoring. We can do quadratic formula, graphing, complete the square. So which one do y'all want to do? Factoring. So we have to find factors of
Negative 4.
that add together to get.
Negative 3.
That's going to be what?
Negative 4 and 1.
Negative 4 and 1. Very good. And what do I do from here then?
You just put them in x minus 4.
How come I can do that with this one?
Because x has 1 in front of it and it's a square.
X has negative 3 in front of it. What has-
x squared
yes.
has a 1 in front of it. So
A is 1. A is 1 right here, so we can just take this and create 2 binomials from here. And now to solve, we set both of these equal to 0. So this one will be 4 and... Alright. We are not done. We have to check it. We have to check it because these will have extraneous solutions. We talked about those are solutions that when you plug it in, it wouldn't work. So I'm going to start with 4 over here. And once we do this one, you really don't have to write it out when you check it. You can just plug it in your head or calculator. But for this one, we'll write it out. So if we plug 4 in, we're going to plug it into x on both sides. So this will be log 2 And when I plug in 4, 4 squared is what? Minus 4? Okay, so I have log 2 of 12 equals log 2 of 4 times 3, 12. Okay, so they equal the same thing on both sides. I plugged 4 in for x in this one and this one. Alright, so now let's check negative 1. I plugged 4 in right here, so 4 squared is 16 minus 4 is 12. 4 times 3 is 12. Alright, so I plug in negative 1 up here, so I have log 2. What is negative 1 squared? 1 minus 4? Alright, so I have log 2 negative 3 equals log 2, and then negative 1 times 3 would give us that negative 3. So it looks like that one would work, but it doesn't. Here's why. So logs are pretty much, you're just finding an exponent, right? So let's write these in exponential form. This one I'll write as log 2 raised to the, and I'm not sure what power, so I'll put x equals 12. How would I write this one in exponential? 2 to the, we don't really know, so we'll put 2 to the x equals negative 3, right? Alright, if we look at this one, there is some number that we could raise 2 to get a positive 12, right? A positive number. It'd be a decimal of some kind. But if we look at this one, is there any power that we could raise 2 to? I know that sounds funny. Any power that we could raise 2 to get a negative number?
Yes.
Alright, which number?
I get negative 3.
Yeah, just any negative number. Could we raise 2 to any power, put any number here to get a negative number? Okay, let's try it. Can I borrow your calculator? I'll give it back. So if we raise 2 to a fraction, so 2 to the, and I'll just do 2 over 3, you don't have to do 1/2, then it still give us a positive number?
Yep.
Alright, what other numbers do you think would give us negative?
Nothing.
Maybe a negative number?
Yeah.
So like 2 to the,
Negative 5.
still gives us a positive number. So is there any real number we could raise 2 to get a negative number? Not unless what now?
Like you put the exponent in a fraction underneath. So like 1 to the 8 underneath it.
Underneath this?
Yes.
So,
1 to the whatever. Because whenever you have a negative exponent, you have to put it like under a fraction.
gotcha. But even if we did that, Chandler, it'd still be a, like 2 to the negative 8?
Right, not unless it's going to be positive.
Yes, it'll never be negative. Unless you plug in an imaginary number, which we're not dealing with right now. So, basically, anytime that you plug in your answers and you get a negative number right here, it is an extraneous solution because it's not going to work. You can't raise a positive base to a power and get a negative number. So the only answer we have right here is not negative 1 because it didn't work, but 4 would be the answer for this problem. So if you plug it in, gives you 2 negatives on each side, even if they are the same, it cannot happen if your base is positive. Does that make sense? Okay. Any questions on that one? Okay, next one. Do they have the same base? They both have a base of what? 3. So we can mark the logs out. We'll have x squared minus 15 equals 2x. So we subtract 2x, we'll get x squared.
Minus 2x minus 15.
So we need to find factors of what number?
Negative 15.
That add together to get,
Negative 2.
that's going to be
3 and 5.
3 and 5, but one of them has to be negative, right? Because this is a negative number.
Negative 5.
So it has to be negative 5. Because negative 5 and a positive 3 added together would make what? Negative 2. Everybody see that? And I could just make 2 binomials because A is what? 1. Oops. Alright, so my 2 x's are what? Good. Alright, and we can just check them in our head this time. We don't have to write it down. So if I plugged in 5 to this one, 5 squared is what? Minus 15? So I'd have log 2 of 10 equals log 2 of 10. So that one works. And this one, if I plug in negative 3 squared is what? Minus 15? Negative what? No. 9 minus 15? Negative 6. I can stop there. I don't even have to check the other side because why?
It's a negative.
It's a negative number, so that one's not going to work. So 5 is the only answer. Will you ever have 2 answers? Yes, you will. On this case, 2 cases, you just happen to have 1 for each. Any questions on that one? Alright, we're going to work one more together, then you're going to do some on your own. Alright, so number 7, marking them out, the logs, because they have the same base. So we have x squared equals negative 6x minus 8. Does it matter which one I move?
No.
You can move both of those on the right side, the other side, move the positive.
Correct. Which one would be less work, moving the x squared or moving the negative 6x and the negative 8? Okay, why do y'all say that even though it's 2 terms?
Because you're going to have to multiply the whole equation by negative ones, that way you can get a by itself.
Not a by itself, but a to be positive, yeah. We don't want a to be negative. So exactly what he just said, it's better to move these two, because if you move this on the other side, you'll have to divide the whole thing by negative 1 or multiply it. So we are going to add 6x, add 8 to both sides. So tell me what the quadratic will look like. Yes. What are my 2 factors that I'm going to use? 4 and 2, good, because 4 times 2 is 8, and 4 plus 2 is 6. So my 2 binomials would be what?
Negative 4, negative 2.
Yes, after I solve them. Any questions before we check them? Yes.
How did you get X? What's 2 and what's 4?
I had to find factors of this last number, my C. And if I write all the factors of 8, it would be 1 and 8, negative 1, negative 8, 2, 4, negative 2, negative 4. And I'm looking for which ones add up to be my middle number, which is 6. So that'll be 2 and 4. So that's where I got these from. Do you have a question, Will? Okay. Alright, so now we can check them. So over here, if we plug in negative 2 squared, that gives us what?
16?
No.
Oh, wait, sorry. 4. I was
4.
thinking of the wrong one.
And if we plug negative 2 in here, we'll get positive 12 minus 8, which is what?
4.
4, so this one's good. This one on this side will give us what?
16.
16, and then negative 4 times negative 6
24.
minus 8.
16.
So both of these work. And why do they work? Because when you plug them in, what happens?
You get a positive.
Positive number, the same positive number on both sides.
That's the same number.
Yes. Any other questions on these? How do we feel about these? Okay? Good? Alright, try 8 on your own, and if somebody comes up here and works on the board and gets it correct, you can draw the box.